Well, good afternoon, and all those who are on time, welcome. Thank you. And those who are watching the recording, I suggest that you skip the first minute or two because I would be waiting for some other children to join the class. Well, shows 19 people are already in the class, sharp at time. Your response is very encouraging to me too. So all these a lot of people. They were there before the class timing started. Pratyusha, Vijalakshi, Arnava, Varma, Shivangi Shah, Priyanshu Yadav, Pallavi Thapar, Mudit, um, who else? Ritesh Wadhwani, Ishan Gupta, Pratham Gupta, Rishika Ghoshal. Rishika, were you able to log in? Navnoor Kaur, Shiven Agarwal, Mudit, Deepak Kalal, Shikha Kotwal, Chetna Shankar, Kashika Sharma, Sana Srivastava, Shreyashi Jha, Khwaish Jaiswal, Shivalik Mathur. Welcome everyone and thank you, and your response, your interest is very encouraging. It motivates me to work more, to give you more time. When children want to learn Mayank Gangwar, Ritvik Bhatia, Adrian Dev. So beginning of the class, I will respond to your good afternoons, but later on, I hope you won't mind, I will not be able to respond. Meeta P. Kumar, can't hear. The volume is low. Even in class 12th, they were saying the volume is low. And I doubt why the volume is low. Can't hear you. I really don't know what's the reason today. Volume low. Volume low, volume low. Uh, really can't make out why. Uh, okay, let me try and speak a little bit louder. If that adjusts the volume, is it better now? See, whenever I speak little louder, people say, I have been taking online classes earlier. Might be YouTube glitch, Sarnaba. It might be. But then whenever I speak louder than what I'm speaking now, people say your voice is jarring. Happening with other streamers also. Yeah, it might be because now the bandwidth is restricted. For these few days, bandwidth is restricted. So it might be. But I will speak little louder and do let me know if my voice is audible now. So Sarnaba is good afternoon. Vanisha Kohli, good afternoon. So welcome everyone. Now I will not be able to respond to good afternoons. Quick, still not audible enough. This I will respond. But now I'm sitting exactly in front of the mic. Now, even now, if it is not good enough, my voice is not good enough, I will have to use the mic, external mic now. Uh, I will do that. I have arrangement for using external mic also, but it is much more simpler and more freeing to use the inbuilt mic of the. Now, okay, okay. Thank you, Shikha. So we have seen few uh, things, and yesterday there was an issue, and some people responded in the Telegram group also. Quickly about these groups. If you join the course on anytimeteacher.com, which I am changing, not audible. Uh, Actually, I'm not. I have the external mic. I do have the external mic, but right now, if I add it, then my tablet on which I write, that will be disconnected. Little better. So for today's class, what I'll do is I will speak little louder. I will speak little louder for today's class, but if you can increase the volume of your computer, that will be even better. Check it out. So if you join this course on anytimeteacher.com, you will get the updates, but then be aware that I am in the process of changing that course. I am not very happy with the course which I have put up. I am in the process of changing it. So these are the ways to reach out to me, which I have put up in the first 2 pages of the course. And quick recap of the previous class. Towards the end, we had these two issues that a car was moving on the road, but the car was not going down. But when this car passes over a pit which is covered with dry leaves, and the driver does not know that there is a pit down, the car goes down. The equivalent of that, we had this system here, we had it here something like this, that this car which was going on the road, horizontal road, it does not go down. You know it very well, है ना? That's the experience that we all have had. On a straight, flat road, pakka road, the car goes forward or back. It doesn't go down. But then somewhere in the front, there is a pit covered with leaves, and the driver doesn't know. So when it comes here, dhram, something happens, the car goes. Question number 1. Why does the car go down? Why does the car go down? The class today is on identifying the forces that are at work. Why does the car go down? I will keep writing here, and if anything that I like from your response, I'll do that also. Why does the car go down? And you down, I mean down the pit. Down the pit. In the pit. Why does it go down? Okay, thus it goes down. Huh? Visalakshi, Shadal, Kevin, Manya Sareen, Pratyusha. Upward force of road is not available in pit. Pratyusha. Question is, why does it go down? Utkarshi, Shikha, Deepak Rajput, Navnoor, Meeta P. Kumar, because of gravity and the upward force was not enough to balance it. Prayanshu, Bhavya, oh, wow, it's so going so fast that now I'm not able to read all the names. But all these are the names of those people who were born intelligent. And remember that I said I don't know whether it is really Einstein who said so, but then they quoted to Einstein that I was born intelligent, but education ruined me. Leaves are not strong enough to support. Oh. Yeah, Mayank now talking more, and there are more people who are said it can also be because car maintains its inertia. Okay, when first question, why does the car go down? Because there is something acting down. The car goes down because something is acting down. You see this blue color? This is the battery, 9-volt battery, which you might have been using had the school been open. I told you I planned sessions in electronics and artificial intelligence for class 11th. You might have been using these things. This battery, this object, this body, this block, if I do not hold it anymore, it goes down. I'm not throwing it. Note it. I'm not throwing it. See, I'll just let it go. It goes down. Why does it go down? Because you people have identified it correctly that there is some gravity acting down. Then my question is, where is my pointer? I have lost the pointer. Oh. Okay, this here. Now my question is, why was the car not going down earlier? This answer was right. What you have given, this answer is right. Okay. कोरोना वायरस 1 2 3 4 5 6 7। देख मजे की बात है, कोरोना वायरस मेरे पास इतना टाइम है लाइव क्लास में भी कि मैं गिन रहा हूँ कितनी जगह पे तूने वो सब लगाया है ना, पर अब नहीं लगाना बेटा, देख रहे हो ना ध्यान भटकता है इन चीजों से। Why was the car? See, car is going down, and you are right that there is a force of gravity. Now I am quoting it, putting it again. Now this is the situation. I am putting it like this. Okay, this is the situation. Because normal force was cancelling, third law, equal opposite, it was because of. Ha. So it means one thing I am very sure, you people have a very good sense, common sense is abundant in you. And if you maintain this common sense, or with the due regard to all the teachers in the education system, if we are not successful in killing your common sense, then you will do very well in physics. So coming back to this, I'll make it a little bit simpler directly. A lot of people giving lot of response, an intelligent response, but I'm not able to read everything. Very good. So just a second, I forgot to mute it. So there is a echo kind of thing. Okay, now. Look at this one. Why is this block? Physics people like to call it a body or thing or object or whatever. See this battery, 9-volt battery, why is it not going down? It was going down. See, it was, you release it, it is going down. Why is it not going down now? Common sense. Give a very straightforward answer. What you are able to see. Why is this block not going down? Remember, you said it was going down because of gravity. But why is it not going down now? Ritesh even knows the word, but how can a road exert normal force if it's not actually moving? Mudit, this question I'm not able to understand. How can a road exert normal force if it's not actually moving? The road is not moving. Yeah, that I agree. But it apply. Okay, I think I'll understand it when the hand stops it. Gravity equal to normal force. Hand is exerting normal force because that force on horizontal movement is zero. Net external force is zero. Okay. So because whatever I'm getting good answers. What you mean to say is my hand is applying some force. Question number one. Are you right? That's what you mean to say? This block goes down and you say because of gravity. Remember, what is the direction of gravity then? A body at rest starts moving in this direction, so there has to be a force in this direction, and the name of that force is gravity. The gravity trying to take it down is not able to take it down. The body at rest remains at rest. Body at rest remains at rest. It means there is no net external force. And you are right in saying it is my hand, which you can see, which is applying an upward force. Okay. So why was the car not going down earlier? It's the same that why is the block not moving? Uh, same. This question is same as why is, I'll put it what it is. It actually is. Why is 9-volt battery not going down? Not going down. Is these are the same. And your answer to this question is my hand is applying force. Agreed? That's what you taught me. My hand is applying force. Now, the direction of this force is upward, that you have already said. That's already that I read. Sir, what I mean is how can a hand exert upward force if it's not moving upward? Okay, good. Mudit, we will come to this question. Please listen to read others' comments also. Mudit has said, unless my hand moves up, Mudit feels it can't apply a force. Whereas others are saying that if this block is neither going up and nor going down, it means the net force on this block is zero. I know one thing. Down there is a gravity. Proof, you release it, it goes down. Why is it not going down? You said because my hand is applying a force. There is a jagada now. everybody else, or say so many of you have said that my hand is applying an upward force. My hand is applying an upward force. That's why this block, which should have gone down if I let it go, it will be too big a bang. So I'll put something below it. If you don't apply anything, this is what happens. It goes down. In this condition, it is not going down because some people, rather most of you say, my hand is applying a force. But Mudit has raised one question, and you are not allowed to say, Mudit, you shut up, you don't speak in between. That you are not allowed to say. Even I am not allowed to say all that. If we, no, you have to answer now Mudit's question, and you have to answer in a gentleman and a lady's manner, sabhyata ke saath. He says, my hand is not moving up. Then how can my hand apply force? I am putting the situation in a different manner. Sir, is it that the hand is applying if we observe in heavy objects? Okay, keep commenting. Yeah, keep reading each other's comment and keep commenting. That's a very good discussion going on. Good discussion, intelligent discussion going on. My way, the way I will present it is this. This block should have gone down, and if it is not going down, the body at rest remains at rest. If it is not going down, body at rest has remained at rest, then net force on this body is zero. Whether I can see it, understand it or not, but net has to be zero because body at rest has remained at rest. And whether I like it or not, whether I understand it or not, or whether I can see it or not, there is some external force in the upward direction. There has to be, which is balancing out something, say, which is not allowing the gravity to pull it down. There is some upward force. Now, out of that entire scenario that you are able to see, what is the possibility? Who is that agent who is applying this upward force? My hand is the only agent because there is nothing else. There are other possibilities. There are other possibilities similar to this thing. Do forgive me that I am bringing in too many things at the same time. This is a weight. And right now my hand is holding it. Holding it means my hand is there down. So it is not going down or it is not going up. Okay. Now I am removing my hand. And my whole experience of living life on this earth says gravity pulls it down and it should pull it down. Gaya hi nahi. Now my hand is not applying any force, but still this weight is not going down. Gravity pulling it down. Do you want a proof? Okay, see the proof. Is the gravity pulling it down? Let's see. Yeah. See, the gravity, if I release it, see gravity at work. Do you see? It goes down. Who pulled it down? Gravity. But then after a while, it did not go down. Let me put up something else. This thing we saw yesterday. Right now, this metal ball is kept on my hand. And so the gravity which is pulling it down, my hand is applying an upward force and the body at rest remains at rest. So I'm removing my hand. It still does not fall down. Still it does not fall down. What is holding it here? Okay. I'm leaving, or what I can do even better, you will understand it better. What do you expect if I if I cut this thread using this scissors? What do you expect? It means what? It means what? If I cut this thread, what do you expect? It means the thread had a role to play in holding this metal ball at its position. A similar role that my hand was playing when it was under it. These are the forces which are at play in the questions that you are going to do in mechanics in class 11th. And to identify these forces, that which are the forces, this law which we started studying 2 days back, this helps you to identify which forces are there. As the topics become more and more complicated and questions become more and more involved, uh, the complexity level of the question increases and they become of engineering entrance or advanced, you will not be able to read in the language of the question which force is acting. You will not be able to read it in the language of the question. But if you have an understanding of this first law, if you have an understanding of the situation, you will be able to conclude that whether it is given in the question or not, but such and such force is acting. There is a force acting. So from here, we move ahead that with these questions that we have done, that this is what, these are the ways that we understand this situation. If speed or the direction, speed or direction. I told you yesterday, there is a sense in saying instead of velocity, saying speed plus direction, there is a sense. Because whether speed changes or direction changes, your velocity changes. So when you say velocity has changed, you actually don't know whether speed has changed or direction has changed. There is a much better clarity of the situation when you say speed and direction separately. So if speed or direction, any of them, if it changes, there is a net external force acting on the body, whether it is mentioned in the question or not. And I hope by all these activities and by your answers, what I can also even conclude that you have understood this thing very well. If the speed or the direction, any of this thing is changing, there is an external force, whether it is mentioned in the question or not. And yesterday we saw this thing that if only the speed changes, and we did it too, if the speed increases, if the speed decreases, then what can you say about the direction of the force? And yesterday I remember everybody gave me the correct answer. Mudit, not always, but in the... Achha, that's okay. You can continue your discussion. So if the speed is increasing, what can you say about the direction of force? If the speed is decreasing, what can you say about the direction of the force? And another thing that I will like to add to yesterday's, this is I'm adding to the yesterday's discussion. Just a second. Not just one force. Say if there is a, I think I did the other way around. The pen which was active, I removed it. Okay, if there is, say the body is moving in this direction, and if v increases, and let's say there is, you said yesterday, you concluded it correct that the force must be in this direction. I am saying, let's say there are two forces, P1 and P2. Now you check your common sense and you will find you have it in abundance. And with your answers, that kind of answers that you have been giving me so far, it is in abundance. V is in this direction and this V is increasing. Can you tell me out of P1 and P2, which one is more? Your cam is blocking. Oh, acha, 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 acha. Just a second, just a second. There are two ways to it. One is that I change, just a minute, or I draw the diagram at some other place. What I'll do is I'll go with the second approach. Uh, just time and again I'm missing out the same part. I'll little bit issues, small issue. Okay, I'm drawing it again. Say this is a body and it is having velocity in this direction, and this velocity is increasing. Now, if there are two forces acting, one is acting in this direction P1 and one is acting in this direction which is P2, can you tell me V in this direction increasing out of P1 and P2, which one is more? Yeah, now I have changed it. In my on my screen, yeah, these are those technical, say, side issues with the technical. Okay. Okay, Manas says P1 is greater than P2. Sapnil says P1 is greater. Shiven says P1 is greater. Ritesh, Bhavya. See, I told before you answered, I told you you will be giving me the correct answer because I am very sure I'm teaching you for the third day now. I am very sure that common sense is in abundance with you. There is this story I'll keep on reminding you for the whole of your the 2 years. I don't know whether it was really Einstein or not. He said I was born intelligent, but education ruined me. And if we as teachers are not successful in killing your common sense, then you will do very well. Keep this common sense intact. See, before I taught you, you knew these things. Remember these days very well. Because of this corona blockage, I have got a chance to talk to you. Remember, you answered these questions before I ever taught you. So it means you knew these answers. I did not teach you. I said, see, if V increases, then remember, children, note it down in your notebooks. Then in that case, P1 will be greater than P2. If V is decreasing, then children, note down in your notebooks that P2 is greater than P1. I did not tell you this. I just said which one is greater, and you have given me the correct answer. Likewise, if the speed is decreasing, you know it very well, P2 is greater than P1. Okay, so moving ahead, and these questions that we have done yesterday, if neither the speed has changed nor the direction has changed, if the speed is same, direction is also same, or one particular case in it, the speed was 0 and it remains 0. So body at rest remains at rest. Then even if there are forces acting on the body, their net is 0. And this is what will bring us to calculate that upward force, the value of that upward force, and little bit of mathematics that keeps coming in now and then. I am drawing it here now. A block, that 9-volt battery is kept on a surface. I am using the language of physics, but then what I'll do is, this is 9-volt battery and kept on a surface. It's my palm. My palm. What is in physics this is called surface, and these things are called object, or they are called body. To me, this body word gives a very different kind of feeling. I feel like some dead body is their body. So I like block. I like calling it more as a block. But then if I know it is a 9-volt battery, it's much better, such as a satellite. Sir, not visible. Oh. Now you know what kind of intelligence I was born with. Second time in the same day, I am doing the same mistake. So 9-volt battery, this is my palm, which you call, and this is, say, call it object, call it body, call it block, or whatever. Now, question for you. Question for you. This block had one force acting down, which all of you knew is the weight. Call it mg, call it weight, call it gravitational force. Whatever word you call, all are same. And we all agree to it, है? But then this body at rest remained at rest. Body at rest remained at rest. What does it say? Then in that case, what is the conclusion? What is the conclusion? The net resultant force on it is zero. So my question is this. This is the force that was applied by me, and I am calling it N for no reason. You can call it R also. R. Both are used in physics, N and R both. But here R can also means force by, you know what is coming up, है ना? Force by Rajiv. So I'm calling it R. But remember, this R is a technical term. In the books, physics book, R is used. Actually, this force is called normal reaction. So some books mention it with N, some books mention it with R, but here it works for me very well because R is the force applied by Raji. Question is this. Listen to the question. What is the question? Which of the two, N and mg, which one is more? Which one is more, N or mg? Which one is more? Ritesh, acha no, you said what is that word? Manas. Do you see? Do you? Adrian says mg is more. So far, Adrian is the only one who is not agreeing with others. Okay, everybody else, everybody else, everybody else, everybody else. नाचे दिखा सपना, पता नहीं क्या कह रहा है बीच में. Both are equal, balance for. Okay, Adrian, if mg is more than n, let's take it some numbers. If say mg is 7, if mg is 7 and n is 5, we did this question on day 1. If this is 7 and this is 5, which side will it move? It will go down. But if mg is 7 and n is also 7, which side will it go? Remember that we did that question on day 1. Which side will it go? And at that time you answered it correctly. So all of you, Adrian, have I been able to answer your have I been able to respond to you in a way that you understand? Out of n and mg, both are equal. Out of n and mg, both are equal. Body at rest remained at rest. Body at rest remained at rest. So it means net force on it is zero. So what is the value, the magnitude? What is the magnitude of n? How much is n equal to? You know, that's one of the questions that you have done now. You have understood that there is something like n. You have understood that. Otherwise, that body would have gone down. Remember that? So now what I am doing is, I will ask this question in a I will ask this question in a different scenario. The scenario which we had in between, and you saw this scenario, there was this metal ball. I did it just now in front of you, and there was a thread attached. Remember that? And I was holding that thread. One thing we all agree that down there is an mg. Down there is mg. Call it weight. Call it gravitational force. Call it gravitational force, whatever you want to call. There is acting down. But then it was not going down. It was not going down. Remember that it was held and it was holding off quite well. Now the thread is cut. It was holding like this. When I use this scissors to cut this thread, somebody said, "वो भूकंप आ गया था," something like that, है ना? It fell down. It means what? It means this thread was applying some force in the upward direction. On this block, if I draw this ball again, then there is this weight acting down, and there is certainly something up. Certainly something up. This force is called tension. It basically means a string has tightness. String has tightness. Now my question to you is this is a question. Is it, call it P, call it T, you can call this P, you can call this T, whatever you want to call, okay? So is T greater than mg, or is T less than mg? And I am expecting correct answer. When it was holding, say in this situation, is T more than mg or is T less than mg? Okay, tell me one thing. If I give, I told you I am expecting correct answer, because I have now seen in 3 days, I have seen your mental level. Huh? Now, second question. If I start moving it, remember this, I am not moving it continuously. If I start moving it up, up, is T greater than mg? This is question number 2. So when you write, you first put 2 dot and then you write the answer, because otherwise there are a lot of questions going on. Okay, so this I am putting it as question number 2. So when you answer in your comment, write 2 dot and then you give the answer. Is T greater than mg if I start moving it up like this thing? Start at the start. See, it is here, and now I start moving it up at the start. Is T greater than mg? Okay, now there is a, what in Hindi we used to see, read one thing na, विद्वानों में भेद है, विद्वानों में मतभेद है, टीम की जन्म तिथि के बारे में विद्वानों में मतभेद है. Okay. So this is, yeah, this is good. Okay, now coming over to the next situation, and I'll answer all these things together. Now there is no string. Now there is no string. Sir, can it be that the thread is not applying an upward force but just holding the ball in midair due to, that is okay. But then now I started moving it up. The body which was at rest, starts moving up. So is T more than mg? A body at rest starts moving up. Is T more than mg? Deepak Kalal says, yeah, एक बड़ा politically answer दे रहा है, yes or no. It can't be anything else. It has to be yes or no. Good, Deepak Kalal. Pratisha says no. This is where I need to get what is there in your mind. We use one term for it. We say, show me your thinking. What is going on in your mind? Show me your thinking. Now, I will come back to this one, but just another thing before we say come to a close. Now the thread is also not there. So, what is holding this weight? What is holding this weight in its place? Same, but force in a hand is causing apparatus to go upward. Okay. But my hand, Pratyusha, you have raised up a good issue. My hand is not in contact with the ball. Pratyusha, a question says, comment for you. My hand is not touching this metal ball. It can't be my hand. My hand is not in contact with it. It is the string which is in contact with it. Okay, now in this case, what is there which is holding this weight in its position? Ignore that slight movement because my hand is not very stable. What is holding this weight in its position? Tension due to any kind of string. Kafi tension. what is holding this weight? But see the difference. See the difference. This was tension in the string, tightness. Tightness. I think I can make you hear this tightness. Do you hear the sound? Because there is tightness in it. This string, when you let it go, this ball stays here. But in this case, the moment you let it go, it first goes down and then it stays at some point. See where it is staying. I am not moving my this hand now. This is the spring. Say this is the say I am not touching anything now. I am just holding it and putting it straight like this, and I let the weight go. See what happens. And somewhere here, now it is at rest. I hope I am coming clearly in this picture. Or what I can do is I can increase the size of this video. Just a second. Okay. Now see. This is the spring, this much long. I am just holding it like this, and I let this weight go. See what happens. And if you stop it, it stays here, not here. If it does not stays here. It stays at rest here. There is a difference between this and this. We are in a class where we are identifying various forces at work. We have not given or we have not got all the answers. We haven't understood everything, but we are understanding, we are getting aware of various forces which are at work. In between, we got a chance to do some calculation, and we even calculated how much is that upward force. And then we got another chance to calculate whether that upward force, in which case is that upward force more, and in which case will the downward force be more. But one more. Now this time I'll have to fix it up to this place. Okay. I think now it is clearly visible. Okay. Now I am applying this force with this string. Okay. And this force, when I apply this tightness, is not moving this body. Now there is no downward, upward. Downward and upward matter is closed. The downward force, gravity, and the force applied by this book upward, they are equal. That we have already worked out. That we already agree that they are equal because this block is neither going down nor it is going up. Neither going down nor going up. It means body at rest has remained at rest in the vertical direction. Now come to the horizontal direction. I apply this force, which we saw the name tension in the string, tightness in the string is tension in the string. I apply it in this direction to my right. I am applying in this direction, but the block is not moving. Same logic that you applied here, same logic applied here. Is that force which is backward more than T or less than T? No, Deepak Karan, I'll quickly close it. I know today the class has gone a little bit longer, but then somehow I'm in mid of something that has to be finished. Yes, Pratyusha, good. You are Mayank, good. You are using word friction. Now, so my question is friction more or less than tension? Very good. You have concluded it right. So I increase the tension. What I was applying as, let's say some numbers, 2 Newton. I am increasing it and I am applying 3 Newton. So what I'll do is, to make it pictorial, I am applying 2. This does not move. So how much is the friction? Question, 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 question. And let me do it in a, just a second. Let me try my best to make my question clearer. Just a second. Okay, I'll put it in this form. This is the block. We are not talking of vertical direction now. This part is already agreed that this N and this is mg, and we agree N is equal to mg. Now what I'm saying is, I am applying say 2 Newton this side, and there is a friction this side. Block not moving, or let's say does not move. Does not move. Question is F greater than 2 Newton, or is F less than 2 Newton? And many of you have answered it correct, that it is equal. So my question number 2 is, if I apply 3 Newton, but still the block does not move, so how much is F? Then how much is F? I will close it with this one. Very good. Okay. The class has gone a little bit longer, but the answers are equally intelligent still. So we have seen few forces at work, and we have seen one thing about this friction. 4 Newton. Shikha, from where did you get that 4 Newton? Question. So many correct answers that I can't even take the names. So many correct answers. If I apply 2 Newton, block doesn't move, friction is 2 Newton. If I apply 3 Newton, so I am making it visual like this. Say I am applying 2 Newton, block doesn't move. I apply little bit more and I apply 3 Newton and the block doesn't move. So it means body address remains at rest, the friction value is 3 Newton. But ultimately, if I apply, let's say, if I apply 4 Newton and say the block moves, ultimately it will move, you know. If you keep applying force, ultimately, you know, this block will move. इस block की हैसियत क्या है कि बैठा ही रहे, हिले ही ना. हम और अप्लाई करेंगे, 5 न्यूटन लगाएंगे, 6 न्यूटन लगाएंगे, somewhere it will start moving. Very good. Adrian has now given a very good answer. Friction has adjusting capability. So we saw few things. Normal reaction we saw. Tension we saw. The force applied by the spring has a feature. When the spring applies force, the spring gets extended or it gets compressed. Spring applies forces when its length changes. If it extends, it pulls both the bodies in. If you compress a spring, it pushes both the things out. And friction, and we saw friction has adjusting capabilities up to a limit. Ultimately, at one point, it happened that we crossed all those limits and we pulled it with, say, 4 Newton or 5 Newton. Ultimately, it will move, and friction no more is able to stop us from moving that thing. But friction has adjusting capability. If you apply little bit, you know, tables, you want to push a table in your room, it doesn't move, so you apply larger force and then it moves. Chair kept on on the ground, anything, any block, anything, you apply little bit force, it doesn't move, you apply larger force, it moves. Friction has adjusting capability up to a limit. So we have seen few forces which are at work. Monday, tomorrow will be a holiday. Tomorrow there will be no class. Monday I'll see you once again at 2 o'clock. So far, your response is very encouraging to me. I feel very encouraged. I feel like, to be honest, I don't feel like closing the class. The kind of answers that you are giving, I feel like uh, continuing the class for longer, but then I won't bore you. You had your class 10th exam, you were looking forward to a good break, but then I had this desire to spend some time with you. Thank you so much for your time. Monday, 2 o'clock, Monday, 2 p.m., we will meet again. Thank you.